Yeah, hello everyone. So welcome back to the session on your stacks. So this is the second session we are discussing here, and with respect to your topic called as stacks here, this is one of the important data structure that we have. We will be using in the coming near future, almost in very many different type of applications. We are actually using this particular topic called as stacks. Okay, like for example, you might have seen just now I have shifted from one application to another application here. I'm just traversing like this, right? So this is what, so the way I'm traversing from one to another is just only because I'm using stacks concept here. The operating system internally has been designed, programmed using stacks. So that's the reason, using stacks and using linked list concept, I'm able to traverse forward direction and in the backward direction. So here the stacks concept has been implemented here in this particular scenario. Now, so in the previous session, we will be discussing about something related to the introduction related to stacks, right? So what do you mean by stack and all that? We have already discussed it. And apart from that, we have also discussed something, I guess, if I'm not wrong, we have discussed about how using arrays, we can represent stacks. Okay, so and we have seen examples also, and we have also seen how the bits of the programs, or you can say the slices of the programs we have seen how to create, how what are the different operations we can perform on this particular stack that we can implement it. I think we have seen something like at push, right? So we have three basic operations that we will be performing on stop, I mean stack, that is push, pop and peek. And I think we have seen the code with respect to that, and apart from that we use it something called as display. Well, display is not a basic operation, this is only for displaying the elements, so we have used it, that's it. But the basic operations that we can perform on stack is nothing but push, pop and peek. So push is nothing but pushing the element at the topmost element, okay, topmost position. Pushing the element at the topmost position is what we call it as push operation. Pop in the sense, just simply removing the element from the array whichever is present in the topmost. Okay, whichever element is present in the top, that we are going to delete it using a pop operation. And if you come across to a peek operation, this will be giving you the element which is present onto the top, means whichever the last element you people have inserted, right, that particular element will be displayed using this peek. This is p double e k, peek. And remember, we if the list is empty, then definitely it is not going to print anything, it will simply say that the stack is empty. So this is what we have actually discussed in the previous session, arrays. So how using arrays we can represent this particular stack, and how these operations can be performed on that particular concept, that is stacks using arrays. Now we will be seeing something like linked list representation. In this topic, we are going to see how using linked list. I think you people are very much familiar now. So if you're not, you people can just watch the previous video so that you people can get a clarity on linked list concepts. So using linked list, now I'm going to represent today how stacks will be represented. Okay, and the operations are same. So there is no difference here. So only three operations we have. You basically know that: push, pop, and peek. So these are the three operations I'm going to perform using linked list representation. So let's see how the code looks like and how exactly it actually functions. So if you see here, the same thing I'm going to do. So today we are going to discuss array representation of stack is completed, and then now we'll be discussing about stack here, linked list representation, what we are going to perform here. So if you talk about linked list representation, I think you people are familiar now. Linked list is represented using a node, right? You people are, I think, very much familiar with this. So it is represented using a node, which actually considers, I'm talking about a single linked list. Okay. So if you talk about a single linked list, you know that it is a node. They are basically represented using a node, and this particular node consists of two blocks. The first block is the one which consists of the data element which you wanted to store here, and the next block what we have is used or represented using a pointer variable called as next, which points to the next node that is present here, or whatever is created. So these are the two elements we have. That is what is saying in this particular thing. So here, please don't mind. Generally, if I ask you how to create this particular node, how to define the structure of this particular node, you know that using structures we can do it, right? How we can do it? Something like struct node, isn't it? I think this is a way how we have defined structures when we were discussing a program in the C++ related to your linked list concept. So how we can write here? Struct node int data. Then what we had to write next, since there are two blocks here, so int data means the data block. Struct node star next, isn't it? This is the way how we have actually defined the structures. Okay, so this is how they define the structure. So the structure consists of two blocks. First one is int data struct node star next. So as I told you, this next is a pointer variable. This is a pointer variable which we are using here. Don't get confused here. This is a pointer variable. So whenever someone asks you what is this, you should be able to say variable. Then that will become wrong. Find using struct node star next. Now in this case I'm talking about stack, right? I'm going to create a node. So here you can give your specific name. If you want to keep this as a node, this name you want to keep it as the one we used in linked list, that's up to you. If not, in this particular scenario I am going to define this particular stack nodes using struct stack. Okay, please don't get confused, both are same. Only thing I just saved, I mean changed the name here, that's it. So here I'm going to write int data. So struct node star next. Okay, don't get confused here, semicolon, since it is a structure we are defining here. So this is what. So if you see here, there is no much difference. Only thing in the linked list, we actually use it something called a struct node. So in this case, I am defining the structure using stack because because the linked list concept, whatever I'm explaining here, this I am using in order to represent stack. So there should be some similarity, right? You should for understanding purpose. So that's the reason I'm writing here something called as stack. So instead of node here, which we have used in unit 2 with respect to your linked list, I'm simply using stack. That's it. So whenever you people are creating a node now, how you people can create it? So if you want to create a node, how did we do that? So new underscore node equal to, we have written some concept, right? Using mlog. How did we write? Struct node star. So in this case, I am using stack. So I will be using here stack star mlog. Okay, don't get confused here. Size of, what did we write here? Struct node. So here I'm going to write struct stack because the structure name, the name of the structure what I'm defining here is stack. So that's the reason wherever we people have written node here, struct node. So if you see linked list, how did I define? Struct node star mlx size of struct node. So in place of node here in this time, I'm using the name what we call it as tag. That is the only difference. Okay, there is no much difference. So don't get confused. This I'll be showing you in the coming session. I mean the coming slide so that you people can understand. So at that time you shouldn't be getting confused. That's the reason I'm just explaining now itself. So as you know, this is all just what familiar we people are familiar. So every linked list node generally consists of two blocks, that is data block and next block. And next is used. So it is a pointer variable which is used to store the address of a next node. Data is the one which is used for storing the data elements. So here this is important here. The start pointer of the linked list is used as top. Now in every, so in the linked list, we know that whenever a new node is created, the address of that particular node we are going to store in a variable. Sorry, the address of that particular node we are actually going to store in a variable here, and that variable is what we call it as a start, right? And here we will be storing the address. So now this time this start I'm going to replace with the name top. Don't get confused, same thing. Start is been replaced with another variable now top. So this time I'm going to call top. So top is nothing but the way how we have used it start, the same way we are using here top. That is the only difference we are having. Not no other difference apart from this particular thing. So here whatever the start pointer we used to have in the linked list, I'm going to replace that, or I'm going to write it as something called as top, because in stacks we said that in stack we can insert an element or we can delete an element at only one particular position, and that position is represented using a variable called as top, isn't it? We have seen already in arrays. So whenever you have having in arrays, what it is, so the first element is 1. So top is initially it. So when you're adding another element here, the top will be present here. So whenever you're deleting an element, this, so you have to delete the last element which has come up. So top will be representing backward. So this will be vanished from here and it will decrement, it will come here. But when you're inserting an element, it will be keep on incrementing and it will be going forward. So using top only, you can delete an element or you can what we call insert an element, and when you are deleting and inserting, that should be done in a one end. That's the reason we are using a top. Same way for linked list also, we will be inserting the element and deleting only from one particular position, because we are ultimately implementing something called as tags. So here the start pointer what we use in order to represent the linked list, I'm going to replace that with a name called as top. That is the only difference that we have in this particular scenario. Okay, so all insertion are done are node. So this is what I said. If all insertions and deletions are done at a node pointed but top. So wherever top is there, from there only you people can either insert an element or you can delete an element. Since you know that tag is called something called as LIFO, last in, first out. So whichever the last element you are inserting will be the first element to come out. Okay, last in, first out. Or you can also call it as first in, last out, reverse. So whichever the element you people have inserted first, that will be the last element that will be represented as a output. Okay, so LIFO and FIFO, that's the thing we are using it. So here that insertion and deletion can be done at the top. So the condition here is same like the previous what we have seen in arrays. If top is equal to null, that indicates that there is no elements that are present in a linked list. So simply you will be saying that the stack is empty. But in case, okay, so we have if something top equal to max. So here in arrays, I just want to show you the difference here. In arrays, we said that if top equal to, I don't know how many of you remember it. If not, if people can watch the previous video. So if top equal to max minus one, then we present it stack is full, or we said something called as overflow. I think these are the two terminologies what we have used when top is equal to max minus one. Why did we use this here, there in that particular thing? Because arrays, because we know there is a drawback in arrays. What is that? Arrays need to be defined. The size of the array need to be defined when we are writing the program. That is nothing but statical. That is static implementation. But whereas coming to linked list here, this is a dynamic implementation. This is dynamic implementation. So until the amount of memory you people have in your system, till then you people can keep on executing this particular programs. You don't have to worry. You can keep on adding the elements. So if you have some 500 GB, you can keep on adding the elements till 500 GB. And you know that 500 GB is a very lot amount of memory that is we are having. So definitely, so that's the reason here we are not considering something like top equal to max minus one here. Only this one we are considering here, because there can be the stack can be empty here. But in this case in linked list, because linked list is implemented dynamically, so whatever the memory is allocated to these particular nodes, what you people are seeing here, this one, this particular node, all these nodes are actually created dynamically during runtime. I think you people know, right? Dynamically is nothing but during runtime. So when you're running the program, you people are actually creating this, I mean the creating that particular node. And how we are creating it, I think in C program, you people are familiar with the function, we call it as malloc, that we have already seen and used a lot of time in our programming. So that's the reason. But whereas coming to arrays are static in nature. So definitely you have to give the size maybe 20, 30, 40. So means there is a limit for this particular size. So that size we have to see that we are not crossing that particular size. So that's the reason, apart from this particular function in arrays, you have to use this also. If top is equal to max minus one, then you have to display stack as well. But coming to linked list, you don't have to consider this, because in linked list we are allocating the memory during dynamically. But only thing what we have to consider here is if top is equal to null, that indicates that that particular stack is empty, and this is the representation of your particular stack. Now if I ask you, now this is a stack and you people can see this is the top element here. Now if I ask you, okay, which one is the first element that is inserted, don't get confused. Don't say that sir 9 is the first element here. No, 9 is not, because you know stack is also called as LIFO, or it is also called as philo. First in, last out. So whichever element you have inserted first, that will be the last that will be removed. But if you see here, this particular case, if you say this is the first element, but this is not the first element that will be removed. This is not the first element that will be deleted. If you say that this is the first element, okay, let us suppose 9 is the first element you people are saying. Then what is the first element that will be deleted here? That should be 5. because this is the last element inserted. But if you see here, the top is representing to this particular node. And I said that insertion and deletion will be done only at a point called as top. So if you want to delete an element, then this is the first element that will be deleted. Means what does that mean? If this is the first element that can be deleted, this is the last element that has been inserted, because tag is the one which follows whichever the element that is inserted last, that will be the first element which will be outputted. So here if you see here, 9 is the last element that is inserted here, and if you're trying to delete an element, this is the first element that will be deleted. So by this what you're understanding, 5 is the first element that is created. 5 is the first, and so initially top is actually here. Okay, initially top is present actually here. So this is the first element created. Since there are no other elements here, so we are representing X. Now after that, when you created another element, I mean data element, you want to insert something called a 6 in the stack, you will be creating this particular new node. And when you're creating this, what you're going, this is the second element that we are inserting it. Okay, so this is the last element. So last element means it will come on top of it. If you see, if I represent stack usual using something called as vertically, if I'm representing it, so 5 is the first element here. See, then 6 will be coming here, 2, 4, so 9 will be here. So when I want to delete, so top will be present here. So which element I'm going to delete here? 9. And if you want to insert any other new element, so that will come on top of here, 10, and top will be represented at this particular location. So here this node, when it is created, this is linked with this. Now, and top will be represented here, so it will simply vanish from this particular location. So it will vanish from this particular. So again, whenever you want to insert a new data element, so new node will be created. I think you people know how to use. So using MLOp, using a MLOc method, you people are going to create it, and this particular new node is created. So now what happens, top should be pointing to this particular location. Now it will be shifting from here to here, and as you people keep on adding, the top will be incrementing like this, and finally it will be coming back to this particular location. Now, from this particular position, if I want to delete an element, 9 is the first element that will be deleted. So when this element is deleted, top will be represented at this particular location. So this becomes your last element. Again, when we are deleting another element now, again top will be coming here. So I have deleted this element and this element. So one by one. Okay, so you people can now understand now what is the first element we inserted 5, because this is the last element that we are going to delete it. This is the way how linked list is actually represented. Don't get confused here. So let's see the operations. What are the operations we can perform? Push, pop, freak, peek. I don't have to explain this. I think you people are familiar. Push is nothing but inserting an element to the top of the stack. Remember this. This is important. Top of the stack, we have to push it up. And whenever you're popping it up, you mean popping is nothing but removing an element. So whenever you're removing an element, you'll be removing from the top of that particular stack. So if you talk about peek here, it returns a value of the topmost element. So whichever element is present in the top. So in the previous slide, we had element 9 in the top. So this particular element will be printed using a something called as a peek operation. Okay. So let's see how push operation is going to perform here. The push operation is used to insert an element that you people know already here. The new element is added at the topmost element of the stack, means wherever the top is located. So if you want to insert a new element here, so that is the last element we are inserting compared to this. So the new node you will be creating here, and this new node you will be establishing a link with here, and you'll be giving some value, something called as 8. Let us suppose this is the 80 want. So you will be creating a new node here, and this top will be representing to this particular location. And whenever you want, so this is the last element inserted, because this is the first element, second element, third, fourth, fifth, sixth, seventh, means backward direction. Okay. And whenever you want to delete it, this is the first element that will be deleted. Then this one. So this is the way how exactly people are going to do it. So you can see here, I have inserted a value. So you can see, have you seen this? So I have inserted a new node, and that node consists of data called as 9. And if you see here, it has been placed here. So this is 1 here, and this is 9, and there is a link. And initially top is presenting to the data where to the node which consists of a data 1, but now it is actually pointing to a node which actually consists of data 9. And if you want to delete this will be deleted, then top will be coming here. Then this deleted, top will be coming, decrementing. But whereas coming to this particular scenario, we are incrementing the values. So how to do that? So we have a code here, algorithm, as well as what we call push operation here, C language code. So if you see the algorithm here, allocate a memory for the new node. So what we have to do first, we need to allocate a new memory for a particular new node. How to do it? I think you people know. So we can use MLOC. Okay, so using MLOC, you're going to perform it. I will explain this particular C code using the dashboard, and I'll show you one by one how the elements have been created and inserted. Okay, don't get confused here. So only thing what we have to take care of here is that if it is a first node, when we are creating it, then you people have to perform something called as new node next equal to null and set the top as new node. Okay, else this particular logic has to be executed. So what is this? I'll explain it when I'm explaining using an example. So don't worry about this. Next, we have pop operation here. So if we talk about here pop operation, okay, fine, then I'll explain it. Yeah, but before explaining the code here, I just want to show you this. This is a stack. This is what we call stack. This is what the drive I'm having here. You people can see here. So in this, I am having some CDs. Can you see this CD or DVDs? Now, if you see here, this particular thing actually uses a stack operation, because if you want to insert a new CD, okay, so new CD will be inserted onto the top, means at this particular position. So we are going to insert the CD at this particular position. But whenever you want to delete it, then you have to delete at this particular position, a particular CD. Now, if I ask you what is the first CD that has been inserted, you will say, sir, this is the first CD. This one is the first CD we are having here. This one, and this will be the last CD that we are going, CD or the DVD that we are going to remove it from this particular stack. This is the way stack actually operates. This is what we call it as piles of CDs, piles of CD or DVD. How we are exactly placing it in this particular thing. Okay, so whenever you want to insert a new CD, you have to insert onto the top. This is the top. And whenever you want to delete an element, you want to remove one particular CD or DVD, you have to remove from this particular top location. You can't remove from the bottom, right? It's not possible. If you want the last one, the first one to be removed, you have to remove all these CDs, whatever we are having here. Everything has to be removed one by one. Same way when you're inserting it, the elements will be coming onto the top. So this is the way how exactly we can see in this particular thing. Okay, so let's go ahead. Okay, so just consider the first example what we have. Okay, I'll explain everything here only so that it becomes easy for you people to understand how the push, pop, and peak operations are actually performed. First, we'll go with the push operation. Okay, so if you talk about in this particular case, the push operation, what is the first thing I'm doing here is first, since this is a first node I'm creating it, so I definitely need some new node. In linked list, we use it something called as struct. If you see here, in linked list, we used to call something called struct node star, then delete beginning nil it. So here, since I'm using stack, the structure is stack here, so I'm using here something called as stack. Okay, so don't get confused. Remaining thing is same. Wherever we have used node, the variable called as node, I'm using here stack. That is the only difference. So what is the parameters I need to pass in order to push an element? So first thing is I want the data value which I wanted to push it. So that is nothing but int value. That is nothing but 9. I've shown you the example, right? So I want to push the data 9. So that will come here. And then what we have here is top. So since we have to know the topmost position, then only we can do it. So I'm going to send that also as a top in this particular location. Now here I'm going to define a new variable, but this time I'm not using new node. If you want, you can use it. There is no big deal. Okay, so you don't have to use pointer only. Pointer is consist of less number of line, the variable. So that's why I've used it, less number of letters. So I used it. So if you want, people can use new node. The way we have used in a linked list, same way you can use it. No big deal. That's up to you, because this is simply a variable and you can create your own variable. So there is no restriction that you have to use only pointer only. But here I'm using star pointers. This is a pointer and this is the one which will create it. So let us suppose the first element which I want to delete here right now is number 5. If you people see here, see, the first element is 5 here. This is what I want to insert it. So let us suppose insert. So I'm going to take the value here is something called as 5. Now that value is present in a variable called as value. Now what I have to do first, I have to create a memory pointer equal to, please look carefully here, struct star stag star. Initially in linked list we used node star. I am using here stag star because I have defined the structure using star. In linked list I used something called a struct node, and then I have defined int data and struct node star next. This is what I have defined in linked list. But now here in place of node, I am using a variable, I mean the name as stag. So that's the reason struct stag here. That is the only difference we have. Remaining process is same. So what we can do here is something like struct stag star malloc size of struct stag. So what it will do, it will create. So what it exactly going to do is, so it is actually what it is going to create. It is going to create a new node here. You can see here when you are printing this pointer equal to struct stack star malloc size of struct stack, it is going to create a new node. Let us suppose the address of this node is 100. Same like the previous how we discussed. The address of this particular node is 100. Now what you are doing, pointer data equal to data, and how I am referring this particular node using pointer variable. So pointer data equal to value. So this is a node for data, right? So what is the data I want to place here? 5. Now it is going to find out if top is equal to null. So initially top is equal to null because we did not create any element. So top is initially null, null in the sense -1. So now I have created a new node, right? Top is initially null, condition satisfied, enter. Pointer next equal to null. So pointer is referring to this particular node, and the next block he is placing something called as -1, and then he is calling top equal to pointer. Now top equal to pointer means pointer consists of address 100. So right now top has come up to this particular location. So top is right now. So what is the value of top here you are having? Okay, I will write somewhere here. Top equal to, right now it is addressing 100. I will add 3 elements. First element is inserted. Again, I'll be calling this particular function and I'll be inserting the values here. So let us suppose this time again I'm creating a new pointer here. See, next time again I want to push an element. Now this time I want to push the data element. So what is the data element we have here? 6. Okay, this time I wanted to push a data element here. So the data element what I want to push here is 6. I'm giving the value string. Same way, struct start pointer, pointer equal to struct node star malloc size of this. So what will happen? A new node will be created. So how to create a particular new node here? So you can see here there is one more node created. Okay, let me make a copy of it. Sorry. Okay, this is there. Fine. So this okay, so when I'm created, this particular thing is created. Now there is a new node that is created, and this is referring now pointer. This has been referred with the pointer. Forget, but now there is no pointer here. This is created, this new node is created, top is equal to 100. Now I have created another pointer here. How the new node I have created, that is referred with pointer. So first of what I have to do, pointer data equal to value. What is the data I have to insert here? 6. I am inserting here 6. Now if I will check that if top is equal to null or not. But do you, what is the value we have in the top here? You can see here 100. So top is not equal to null, means this is not the first element we have created. We are creating another element. So the if statement will not be executed. The if statement fails, and then the control will be coming back to this particular location. What we have is else part, and in this what we are doing, pointer next equal to top. Where is pointer pointing to? Let us suppose the address of this is 200, so that 200 will be present in this particular pointer. So pointer next equal to top means pointer is pointing to this particular node. In the next block he is keeping the address of a top. Top consists of the address what it is 100. So that 100 I am placing here. So a link is formed from here to here. Did you see this? This is the way how exactly this particular thing works. Now, as I told you, we can do insertion and deletion only at one particular location. We call it as top. But right now, top is pointing at this particular location, but we already have another node. So definitely this top should be pointing to this particular node now. So that we have to increment it. How can we increment here in this particular case? If it is array, you people did something called as top plus plus, right? But in this case, linked list, we cannot perform this. So what we have to do here in this particular case, I'll be simply using top equal to pointer, because top should come to this particular node, and this particular node consists of address 200 that is present in pointer. So simply I'll call top equal to pointer. So what pointer consists of address here? 200. So top is equal to 200. So top will right now come up to this particular location. So I hope you people are getting. So with this, you can remove a top from here. The top has come up to this particular location. Okay, I'll write it neatly here. So right now the pointer, so pointer is vanished now. You can say this is your top. So top equal to how much here? 200. So this is 100. Fine. Now what is the next element I wanted to create now? Next element what I wanted to insert, let us suppose I want to insert number 9. I want to insert this time number 9 here. Same process. So pointer equal to struct stack mlog. So what happened here? New node you people have created it. Since you have created a new node here, so that new node comes up here in this particular equation. So since how you're pointing that new node with pointer, pointer equal to this now. So this will be becoming your now pointer. Now what is the address of this pointer? Let us assume 300. Okay, now what I'm going to store the value pointer data equal to value. What is the data value I want to store here? 9. Fine, that's done. Again, we'll check the condition. Is it the first node I'm creating it? Top equal to null, but top will consist of address 200. Means this is not the first node I'm creating it. So I am going to simply skip this particular if condition and I'll come to the else part. Pointer next equal to top. Where is pointer here? Here. Pointer next block equal to top. What is the address present in top here? 200. So that 200 I'm placing here, and a link is formed from here to this particular node. And since I told you top has to be incremented, so because a new node is created, it should point to the new node. So top equal to how much? Pointer. So top equal to how much? Pointer. So pointer is referring to the address here 300. So that means now the top is coming to this particular location. So this is something 100, 200, and this is something like you have. So here you will be having pointer also, and here you will be having top also, which is referring to the address 300. Okay, fine, done. So three elements I have inserted. I hope you people are getting. Now let's see the peak operation. I want to implement the peak operation here, this side, onto your right hand side. You see, int peak struct stack top. So I'm trying to get the topmost element. What is the topmost element I have here? This is the topmost element I'm having. So I'll first check the condition whether the whether this linked list is empty or not. How can I determine top equal to null? If top is equal to null, you can simply print a statement here that the stag is empty, written -1. But if you see here, this is a linked list we created. What is the value we have in top here? 300. 300 equal to null. Null in the sense -1. But this time the condition failed here, isn't it? So what we are going to execute? Else part, return top data. So whatever the data block is there for this particular node top, print that particular data. What is that? Top is pointing to this particular node. In the data block, what is the data we have here? 9. So it will simply provide the output as 9. But in case if there are no elements, it will simply return -1. Since we have elements here, so it is simply representing the data. What is the data we have in this particular node? 9. This is the topmost node what we are having here. Now we will see how we can delete it. Now, as I told you that insertion and deletion will be done only on one side. So at the top, right? So top is right pointing to this particular node. So this is the first element which will be deleted. Now, if you see insertion point of view, this is the first element we have inserted. This is the second element, and this is the last element we have inserted. But when we are deleting it, this will be the first element. This will be your second element and this will be your third element which will be deleted. Means whichever the element you have inserted in the first will be the last element that will be deleted, and whichever the element you have inserted last will be the first element that you're going to delete it. So how to delete it? This is a code for that. Simple. Stack pointer. You're going to take a pointer variable here, pointer equal to top. So you see pointer is equal to top means right now pointer equal to top. What is the address present in the top here? 300 means right now the pointer is pointing to this particular node. Okay, now what we have to do? We have to find whether we are trying to delete the element, then if the list is empty or not. We have to find whether this particular list is empty or not. So for that, we are checking this particular condition. If top is equal to null, what is the address we have in top? 300. Is 300 equal to -1? Well, condition fails. Stack is means there exists some elements in this. So simply you will be jumping back to the else statement. You'll simply skip that if statement and come to the else statement. So what do you have to do? So I have to delete this node. Okay, let me erase this. So I wanted to delete this particular node. Which one? This particular node. So how can I do? So when I'm deleting this node, the top should be pointing. Top is the main variable we have. So top should be pointing at this particular location. So how top can point to this particular location? So definitely top should be equal to address 200. Now how can I get a top equal to 200 here? Top equal to, so right now top is pointing to this particular node, and in the next block of this node consists of address 200. So can I write something like this? Top equal to top next. So what is top next here consist of? 200. So that 200 I'm giving to this top. So simply now the top will skip from here and it will be jumping to this particular location. Okay, so top has come to this particular location. Now what we have to do, I have to print the data that is present here in this particular location. And then I have to delete it. So what is the data I have? 9. I want to print it. How can I print it? Since top has jumped to this particular location, I can't use top. But I have another variable which is pointing to this particular node. What is that? Pointer. So can I write pointer data? Is it possible to write? So simply I'll write a print statement. The value being deleted is %d, and %d is the one which will consist of pointed data. What is the data we have here? 9. So that particular 9 will be printed. So the deleted, the value, so and all. So the value being deleted is 9. So this is deleted. Fine. But as I told you when we were discussing about linked list, once if you are deleting any node, you have to free the memory that is allocated to that particular node. So how can I free that particular thing? So we have a method called as free function, right? So using free, I have to give it. But whenever I'm using a free here, I need to give some parameter here. So what kind of parameter I can give here? So means for that particular node to free, whatever the variable that particular pointing to that particular node. What is the variable that is pointing here? PTR. So free PTR. Simple. So then what will happen automatically? This particular thing will get deleted. Means the address 300, whatever we have allocated here, this will be simply vanishing now. So you can see here this particular thing has vanished. So this is vanished. Now top is pointing to which particular node? This is the node the top is pointing here. And then what we have to do if I want to delete one more element, so whichever is present onto the top, that will be deleted. So what is the next element? We are going to delete 6. Same process, stack pointer. So pointer equal to top. So when you're writing pointer equal to top, so top consists of address how much? 200. That 200 you are storing in pointer, means right now pointer is at this particular location. Now we will find whether the stack means this particular stack is empty or not. Top equal to null. Top consists of address how much? 200. 200 equal to null. Condition fails. Comes to the else part. So top equal to top next. Top equal to top next. So what is the next block of a top consist of your address? 100. That 100 I am giving into top. What will happen now? Simply this particular top will jump from this location to this particular location. Top. I hope you people are getting it. Now what I have to do? So simply I have to print that the deleted element is 6. How can I do it? Pointer data. This is data. So when pointer data. So using pointer data, I'm going to print the statement. You can see here the value being deleted is percentage pointer data. Now what I have to do? I have to simply free this particular node. How to do it? Free. And that particular node is pointed with a variable called as PTR. We have already have PTR here. So PTR. So simply it will remove this particular node also. This is the way how exactly people this particular thing works. It's a very simple, very simple when compared to insertion, deletion, and whatever we are discussed in linked list. Only small topic. That's it. Now this is also done. So this node is also removed. Okay, this particular node is also removed from here. And then again, you will be removing this particular node. How to remove this? Same process, but this time, please concentrate here. Pointer. So initially pointer is coming and pointing to this. Now this time top equal to top next. This is what I wanted to explain you people. Top next. So top next means what is the value we have here? -1. So top will be initially equal to -1. Now the top is assigned -1 means there are no more nodes that are present in this particular location. So what we had to do, this is done. Now what we had to do, we had to print the value here. So whatever the deleted element, what is the deleted element we are deleting here? Pointer. So pointer is pointing here. So pointer data, that is 5 is the one which we are deleting it. Then free pointer. So when you're freeing this particular pointer, what will happen automatically? You have removed. So we don't have any other pointer right now. So all we have simply pointed free, so no pointer. And next time when you're trying to print it, remember, next time when you're trying to delete an element, do we have any elements here? No, we don't have any elements. Now this time if condition will be true. See, if top equal to null, what is the value this top consists of? -1. So -1 equal to -1. Well, this time the condition satisfied. It will simply print that stack underflow. If you want, you can write something like, okay, there are no elements present in the stack. You can write that also. No big deal. So here he's saying stack is underflow means you're trying to delete an element when there are no elements present in that particular list. This is the way how exactly this particular thing works. Okay. So I hope you people got it. If people have understood how this particular logic works, it's very, very easy. And what is the next one we have taken here? So something like this. And what is the values we have inserted here? Something 5, 6, 9. What is the address we have here? 100. And that 100 we have placed here, right? Like this. And it has 200, and that 200 we have placed here, right? Like this. So here we had something 300, and the top is actually pointing, sorry. The top is actually pointing to this particular location. Now I'm going to explain your display. Display is very easy. Simple. I'm going to take a pointer variable. That pointer I will be pointing to the top. Means pointer equal to top. So top is this particular node. Simple. First I'll check whether there is any if is a particular list is empty or not. If it is empty, simply I'll place. So top is equal to null. Stack is empty. Else, while pointer is not equal to null, simply print the data and move to the next node. This is what I'm going to do. See here. So if you see here, top is equal to null. Top is pointing. What is the address top is having here? 300. 300 is not equal to null. You'll be coming to the else part. While pointer is not equal to null. Pointer does pointer. So pointer is pointing to top. So pointer also consists of address here 300. It is not equal to null. Good. Print pointer data. So pointer data means this one. So what is the output you people are going to get is 9. First you are going to get 9. Next, pointer equal to pointer next. Now you people are doing pointer. Okay, let me write it here. Pointer equal to pointer next. So what is the address present in pointer next? 200. That 200 you're pointing into pointer means what does that mean? This particular pointer is going to jump to this particular location, because the pointer next consists of address 200. Now pointer has come up here. Now now you will be printing it. Okay, this loop will be continuing, inner loop will be continuing here. So again you'll say, well, pointer not equal to null. Obviously pointer, what is the value pointer now consists of? 200. 200 is not equal to null. What I'm going to do, print the data. How to print it? Pointer data. So pointer, what is the data consist of? 6. That will be printed here. Now again, pointer equal to pointer next. What is the value we have in next in this particular pointer? 100. So this time pointer will be equal to 100. And now this particular pointer is going to jump to this particular location pointer. And when it is coming to it, simply while pointer not equal to null. So pointer is right now pointing to 100, condition satisfied. So what are you going to do? Pointer data 965. And then pointer equal to pointer next. Now this is important. Pointer next consists of x, means null -1. Now this time pointer is equal to how much? -1. So when it is again coming back to execute while pointer not equal to null, but this time pointer consists of -1, which is not equal to -1. That is condition failed. So you'll be coming out of it and it will simply return the top. So you have printed the values 9, 6 and 5. So this is the way how exactly this particular program works. Yes, you people have successfully completed using a linked list representation of a stack. So using this statement, four different slices. Slice number 1 for push operation, slice number 2 for pop operation, slice number 3 this is for peak operation, and this is a slice number 4 which we are performing display operation. Your task is completed. Only thing you have to do is the body part. That is nothing but a structure. Stuck whatever the variables we have that you wanted to define it, so that you people can stuck provide the structure that I will show you using this C++, okay, during the program and all I'll explain it. So this is all what we have for this particular thing. I hope you people have understood how exactly this particular thing works. It's very, very, very easy. Only these things you people have to join together and finally your program is completed. And that's what we have in this also. So I have already explained it. This is related to your push operation and this is related to your pop operation. So whatever I did it. So top now. So this, sorry. So top. So whenever you want to delete, this will be the first element that will be deleted because this is the first element that is inserted. Next, this will be deleted. Next, this one, next, this one, next, this one, next, this. And this is your first element you have inserted. So this is the last element we are deleting. That's why tag is called as first in, last out, or last in, first out. So this is the last element we deleted here. And that becomes the first element to be deleted. That is what he means to say here. So the operations, whatever we have discussed, it's the same thing are provided here. If people can just go through it. So yeah, this is sorry. This is something peak and your display operation, whatever we have discussed just now. So this is all for today's session. What we have with respect to your stacks representation using linked list and how the different operations we have performed. In the next session, we'll discuss about the various applications that are related to this particular stack. We have so many different applications, but before discussing them, we will be discussing about something called how in C programming we are going to implement stacks using arrays and stacks using linked list. Nothing but whatever the slices I have shown you today, tomorrow I'll show you total program, okay, in inbuilt program, so that you can understand how easy it is to write and you construct that particular program. Only thing what is required here is your practice. So I just keep on practicing this particular concepts and try to complete. As much more you practice, the more easily you people will learn it. So this is all for today's session. Thank you for watching.